Hi everyone, welcome to Practical 1 and Practical 2 recording. So I have saved a new project which is P1 underscore P2. So for those who are just starting with ArcGIS Pro, it is good to first create a project, save it, and link the data with its in the folders. So to link, you just need to right click and add to folders. Since I have already linked, so I won't be doing it again. So let's start this practical. The data is about Colliambly area. So this one is the boundary, or which we call CIM mask. So I can change the symbology so that I can have a look. I will say a black outline. So now you can see where my study area is located on top of this base map. The second part of data is the location of piezometer along with the data of water depth, which is the relative water depth. So if we open the attribute table, you can see these two columns which tell us March relative depth, and this is the September relative depth. So the first step was, since it is groundwater, so it has to be from surface to downward. So we have to have these values in minus, in negative. So we have just created relative new fields, and we call this one for March RD03 alt. Altered means, and this is September altered. So we just created new fields, then using the calculator, we calculated these on the basis of these. Just multiply this field with -1. That was the first step, which we have already done. I'll be loading the other part of data so later on. So let's start doing the model. So first, what we have to do is, because for groundwater modeling or monitoring, we need to fill this surface, because we know what is the relative depth of water at this particular point in March and in September, and here as well. But what is the value of water depth or water table, or between these points, between these 2 points, we don't know. So for that, we need to do the in geoprocessing tools, we have an option to do interpolation. So the first step was to do interpolation. You can do simply an interpolation by clicking on the analysis tools, and from there you can search a toolbox, search a tool, which is, in this case we are using IDW. So it's a good idea to have a little bit search on different methods, such as IDW versus kriging, and then we have different types of kriging as well, such as regression-based kriging. So, but for now, IDW is good, because in case of groundwater modeling, we can use IDW with fair good results, but you have to experiment if you want to look for a good method of interpolation. So what you have to do is you have to validate your model. For example, if you have about 110 points, so just take 100 points and for interpolation, and validate those with the rest of 10% of your data. So anyways, I won't be doing IDW. I will not run. So here we have to actually give an input point feature. That should be this one. Z field is the field which will be interpolated. And the rest of the options we are leaving as default. But the aim of this exercise is we need to create a tool to aid production of groundwater surface models for use in groundwater monitoring. Okay, so we are creating a model. So to create a model, you can just create a toolbox. So first step is to create a toolbox. So we call this toolbox as class maybe, or exercise 2, and save it. So here in the toolboxes, we have these toolbox. So in case of exercise 2 toolbox, we will create a model now. Now you can see we have a model here. Now we have to, what we were doing step by step in various geoprocessing analysis options, we'll be doing these in an automated way or semi-automated. So for that, first step in first part, we did simple interpolation of this data. So what we have to do is we have to give model a data input. So the data should be like this, and then we have to have our model. So search IDW and just drag and drop in the model pane. Here in ArcGIS Pro, you can see we have two panes. We can make more we like. Here is our map view, and this is our model view. So what we have to do is we just link this data, input data, with the model. And when I release the cursor, it will give me option that what it is. So it is the input point feature. Now you can see the colors have been changed. And as mentioned, we need to change the field which we are going to interpolate. We have to interpolate both of these depths. So for now, what we are going to do is we are using RD03 alt as a Z field. Output raster name we can change IDW03 underscore 1. So I will remember what I'm saving. Rest of the options have to be the same. So in order to run the model, you can right click on this pane and run it. So it has run, but it has not added into the display because I didn't ask this to add display. Now when I click, the data will be displayed here. So we have, you can see here, the data is displayed. It should be at the bottom. So now you can see that we have groundwater depths. So this is my pixel values. These are the data, right? So this is the water depth. Now you can see that we have water depth surface for whole of column rather than a bit more. Why it is so? Because we have not restricted this in the environments. So we can change these things in our environment. We can have a setup. But for now, this is fine. Now you can see once we have run the model, it is having a little background here, which means that we have run this model again. So it is a good idea to validate the model again, right click, or you can validate it from here. So from now on, I will be using this model builder ribbon to perform these tasks. Now you can see when I click on the validate, it has removed the background. So the model is kind of fresh again. To run another version, to have another run, or we can modify and run it again. Okay, so it is good idea to auto layout so that our model looks a bit more organized. So this was the first step. Now in second step, what we are going to do is, if we look into the output of this, the first thing is you can see that we have data outside the column. So in first place, we will be removing those points from our analysis because we want to have the optimal setup for the analysis. So these data, they should not be used in our modeling. So what I will do is I will select only those piezometers which are inside the BIS boundary of Colli-Ampli. Okay, so for that, this is very easy. I can first delete this model, this tool, IDW tool. So now we have here CIA mask. So we will select only those points which are they are within this CIA mask. So for this, in geoprocessing tools, we have select by location tool. So what it will do is I simply dragged again. So I click this one and I'm saying this is my input feature. And I need the select feature, and select feature, as we know, is CIA mask. So I again connect. So in order to connect, just click outside this CIA mask data. So it is not checked, and now I can connect. So this one is my selecting feature. Now you can see the model has been updated. It has changed its color, and now I have to, if I move my cursor on top of it, you can see the relationship is intersect. So we need to change certain parameters of selection criteria. So we want completely within. This is the option, and then it should be new select, and selecting feature is CIA mask. So if I go back and do a little bit more data exploration, so if I go to attribute table, you can see here I have total 237 records, and some are outside this Colli-Ampli mask or CIA mask. So let's close this attribute table and see how many are those. This model up till now will tell us the result. So again, click on the model builder and run it. So when it will run, you can see it is highlighted in the background. It is telling us we have run this model once, and let's see what is the impact of this run. Now you can see that all those piezometers which are Let me zoom to layer. These are now selected and the rest are not selected. So let's see how many of those are there. You go to attribute table and you can see that we have 237. Out of 237, we have selected 220. So 17 were outside this area. So we should not be using those ones, right? And at the same time, what we can do is we see that this is our mask. So this is our interpolated data. And when we will do any further calculations, such as volume calculations, we don't need the output outside this column area. So we are estimating right amount of volume underground water in the VADOS zone, which is basically the unsaturated zone. Okay, so the next thing is we have to again validate it so that this one comes here. So another thing is the next step should be in the next step, what we have to do is we have selected this one, and now we can run the interpolation again if we want to on the basis of these only. But we have another task, which is you can see using this information, we need to remove those piezometers which are very close to this irrigation network, which we call water network. And if I click on the attribute table, so it is good to see what sort of data we have. So here you will find one variable which is channel type, _type. And we have supply channel, we have drainage channels, and we have escape channels, right? So what will happen, the water flows within these channels, and we are calculating what is the groundwater depth. But at this point, if we compare these 2 points, this is very close to, let me zoom in a little bit more. This one is very close to our irrigation net channel. So if you write on at the bank, and this one is little bit far, the other point. So what will happen, the water is going to seep into this area, the neighboring area from this water network or irrigation channels. So the value of water depth, relative water depth at this point or at this piezometer location is little bit exaggerated. So from our analysis, we need to remove these points. So this is the next task. So now we know that 220 have been selected and we need to remove those points. And this is our task to see, okay, what can be a good analytical approach to find those points, those piezometer locations which are not required or which should not be used in the analysis. So for this, what we will be doing is we'll be running another location, select layer by location tool. Again, go and search select by location tool is here now. Okay, so this is our output of previous selection, which contains the points which are selected. within the CIA mask area, right? So I will give this one, the selected features, as input feature to the model. And we need, similarly as we have done here, CIA mask. So this time our input should be, let me drop it here, should be WordNet. So this is our selecting feature. And now what we are saying that they should be at a certain distance. So we have to change the relationship. So here we have an option within a distance. And say, for example, maybe let's say 120 meters, and selection type has to be changed because we are working on this data which is having some selection about 200 points. We need to remove those points which are not suitable for the selection. So selection type should be removed from the current selection. So it will remove from the current selection. Okay, now let's run this model and see, validate it again. Auto layout, so we know where is what. Nice and tidy diagram has started to build. Okay, so we had 220 points. Now when we will run, you see when the model is running, it is turning red. The model is complete. Let's go back and see what is the impact of this. Now you can see lesser points are there. So this point which was very close has been removed. And now when we will do interpolation, we will get better or more representative results as compared to this previous time. So let's see how many points are remaining. You can, because we are working on this is our main select feature, input where we are, the feature we are selecting. Now you can see from 200, we have removed a huge number of piezometers, which should not be used in that particular analysis. So I will close it down. And again, let's do the analysis inverse distance weighting interpolation. So I will just click here and add IDW tool in our model, close it. We can move this one. So this is the area where we have now 46 points have been selected from this shallow piezometer data. Okay, and now just click and drop to the IDW input feature. Now we need to change the field which we are going to interpolate. It should be RD0303 alt, right? And you can give this one a new name. So this time I will say IDW underscore 03 underscore 2, and I will click OK. Right. So we will run this model. Before running this model, we have to validate. So it's a good idea to validate it. So I will say auto layout. Now it is more clear. I have just fit to window. I've clicked fit to window. Okay, and next, now I will say it add to display. This time it will be there automatically, and then we will compare these two runs separately, compare with each other. So let's run this one. Now you can see the model is running, and Okay, now it has run. Okay, now we can see that